Okay, so we are starting our Unit 3, discussing our quadratic functions, basically the graphs and different representations. Some of this will be review and some of this will be brand new. I want to start by looking down here at this graph and remembering some things that we've learned before. So the shape of the graph is called a parabola. So don't forget that this is a U-shaped graph called a parabola. And the vertex is that point at the tippy top. And in this case, our vertex is not at an integer point. So here's my x-axis. So it goes over 1, and it goes up 1, 2, 3, 4, and let's say a half, 4 and a half, okay? And this vertex is at the top of the parabola. So this vertex is a maximum. If I had a parabola that looked like this, our vertex would be a minimum. And it's kind of common sense by definition. It's the smallest point here, the minimum point. It's the highest point here, which is the maximum. Okay, our axis of symmetry runs through the center of our parabola, and it cuts it in two. That's where the symmetry comes in. And it is a vertical line that goes through 1 on the x-axis. So the equation of the line for the axis of symmetry is x equals 1. Remember, all vertical lines are x equals some number, kind of like our constant function that we just talked about at the beginning of the year. The axis of symmetry always has to be written as an equation, x equals whatever that x value is. And because it runs through the center, the vertex, the x value of the vertex and the axis of symmetry should always be the same. Our y-intercept, by definition, is where the graph crosses the y-axis. And so this y-intercept is 0, 1, 2, 3, not quite 4. So let's do 0 and 3.5. Okay, and then when we talk about x-intercepts, that's where the graph crosses the x-axis. So how many of those do we have? We have one here and we have one here. So we have 2. We won't always have two, but most of the time we do. So what are our x-intercepts? Here's 0. And so this one's, I would say, -1. It's a little further. We'll say -1.5, 0. And this x-intercept is 1, 2, we'll say it's 1, 2, 3.5, 0. Remember that our x-intercepts have lots of names. So I may ask you for the x-intercepts. I may ask you for the roots. I may ask you for the solutions. And I may ask you for the zeros. All of these are looking for the x-intercepts. Okay, now let's go back up to the middle section. So hopefully you remember this first part from your transformations of parent functions. If A, so look at our little samples up here. We have A here, we have an A here, and we have an A here. So A is always going to be that number in front, that leading coefficient. If A is positive, the graph opens upward. And if A is negative, remember it's reflected across the x-axis. So the graph opens downward. So if we look again at our graph here, this graph opens downward, which means we have a negative leading coefficient. All quadratics have a blank, which is the turning point of the graph. So if you follow this graph, you're going upward until you get to the top, and then you turn and you go downward. So that turning point is the vertex. Quadratic graphs are symmetrical across the axis of symmetry, which runs through the vertex. And we have a formula to find that we only need when it is in standard form. Okay, so a quadratic function crosses the y-axis at the y-intercept. And every y-intercept always has an x value of 0 because remember, it's on the y-axis, so that x value is 0 on the y-axis. So for a parabola, the y-intercept will always be 0, and then whatever the y value is. And in our standard form, it's going to be our c value, the constant term at the end. And then a quadratic function crosses or touches the x-axis no times, 1 time, or 2 times. And we will discuss those. All right. So now let's get started talking about our 3 forms. The graph of a quadratic function we just mentioned at the beginning is called a parabola. And there are 3 forms of a quadratic equation. They're all shown right here. This one should look familiar to you. It's called standard form. This one should look familiar to you also. It's called vertex form. And this one, I don't know that you've ever discussed it, but doesn't it look like something, a quadratic that's been factored? So we call this one intercept form or factored form, either way. Okay, so actually graphing an equation that's in standard form. So the very first step is to identify the A, B, and the C. And they are just like they're supposed to be. A is the number in front of the x squared. B is the number in front of the x, and you have to be careful and take the sign with it. So it's a -8. And C is that last constant term. I'm looking at my A value, which is a positive A value, so that tells me my parabola is going to open upward. And if a parabola opens upward like this, then that means there is a minimum value. Okay? So now we're ready to talk about the axis of symmetry. When you have an equation in standard form, the way to find the axis of symmetry is this formula, -b/2a. So I take my b, first of all, it's a negative, right? A -b/2a. My b also happens to be a negative. So we have to make sure we put both of those. And then it's divided by 2 times a, and my a is 4. So we have a negative, which turns into a +8, divided by 2 times 4, which is 8, and 8 divided by 8 is 1. So my axis of symmetry is x equals 1. Don't forget the x equals. Now, as we talked about on the other page, my axis of symmetry is going to be the same value as my x value of my vertex. And because I know that, now I can find the y value of my vertex. So I'm going to go up to this equation. I have 4, my x is 1 now. So 4x squared minus 8x plus 1. And as we said, I know what my x value is now. I can find what the y value is. So 1 squared is 1 times 4 is 4 minus 8 plus 1. 4 minus 8 is negative 4 plus 1 is negative 3. So here is my vertex. So let me back up a minute. I have my axis of symmetry going through x equals 1. And I draw that because if I identify my axis of symmetry first, I can it cuts my work in half. My vertex is 1, negative 3. So 1, negative 3. There's my vertex. Another easy point to figure out is your y-intercept. Your y-intercept, remember, is the c value. So up here, 1. And the x value is always 0. Now, our y-intercepts don't always fit on the graph, but if you can find that y-intercept, it helps you out. So using that axis of symmetry, because I have my y-intercept of 0, 1, it's one space away from my axis of symmetry. So if I go one space on the other side, I now have a second point. Now, if I just connect these dots, it's going to look like a V. And the parabola does not look like a V. It looks like a U shape. So I have to make sure to use a U shape. And because I want you guys to practice this, we can't always use the y-intercept. So let's go ahead and find another value. So I'm going to make a table. I'm going to put my vertex in the middle of my table, 1, negative 3. And if I go 2x values to the left and right, I have 0, negative 1, and I have 2 and 3. I've already found 0, 1, and 2, 1. And do you see the symmetry happen in my table? So if I plug 3 in, substitute 3 in into my equation up here, I have 4 times x squared minus 8 times x plus 1. I'm going to plug in 3 this time. So 3 times 3 is 9, and 9 times 4 is 36. 3 times 8 is 24 plus 1. So 36 minus 24 is 12, plus 1 is 13. And I'm going to see that that does not fit on my graph. So really, this is all I can do. But my point that I wanted to show you is that because of that symmetry, I automatically know this point also. So I will connect my points and make sure to make it a little bit like a U. Remember, because of the 4 in front, that's a vertical stretch, so that's why it looks so narrow. All right, so this is the U try. So I would love if you would pause right now and try this on your own, then you can unpause and check yourself. Okay. So I'm going to identify my key features. So my A is negative 1/2, my B is 2, and my C is negative 1. Because my parabola has a negative in front, I know it's going to open downward. And because it opens downward, that means I have a maximum point at the vertex. To find my axis of symmetry, I have my formula. negative b over 2 times a. My b is 2. My a is negative 1/2. So I have negative 2. Half of 2 is 1, and that's negative, so I get 2. So my axis of symmetry is x equals 2, which means my vertex is 2. So now if I take my equation, negative 1/2 x squared plus 2 times x minus 1, and I will substitute my 2. So I have 2 squared, which is 4. Half of 4 is 2, and that's a negative. Plus 2 times 2 is 4. Subtract 1. So negative 2 plus 4 is 2. Minus 1 is 1, which means that my vertex is 1. So we have our axis of symmetry at x equals 2. So there's my little invisible line of symmetry. My vertex is 2, 1. So it goes right here. My y-intercept is at 0, negative 1 because of the c value. So 0, negative 1 is here. I notice that it is 2 spaces from the axis of symmetry. So if I move 2 spaces to the other side, then I have another point for negative 1. So if I'm trying to make a table, I put my vertex in the middle, 2, 1, and then I will go left, 1 and 0, right, 3 and 4. I already discussed 0, negative 1, and 4, negative 1. So let me find what these other values are. So I'm going to substitute 1 because it's pretty simple. So I have a negative 1/2 x squared plus 2 times x minus 1. And I'm substituting my 1. 1 squared is 1 times negative 1/2 is negative 1/2 plus 2 minus 1. So negative 1/2 plus 2 is 1.5. Minus 1 is just a half. All right. And because of my symmetry, I get a half here also. So 1.5 is going to be about right here and about right here. And when I connect my dots or my points, I have a nice U shape there.